through 5, something like that. So, number 2 asks the question, what is the residual for this data point, okay? So I have my trend line, or what's another word that we're seeing on this page for trend line?
Residual.
Not residual.
Regression line.
Regression line. A trend line is a regression line. Okay, so we are looking at a regression line. And so in order to calculate the residual, we already said that we're going to take the actual value, which I believe everyone had the same actual value. What was this?
68.1.
68.1. And then we subtracted out the predicted. So I need to figure out what my predicted is.
You're going to plug in 1950.
I'm going to plug in 1950. So add a calculator page. M1 of 1950.
I know that.
64.01. Okay? I need y'all to pay attention to this, and I need you to take a note about this, because this is what I'm about to talk about is really important. When I subtract these two, I get 4.09. What is that 4.09 describing?
The residual word, what?
But what is a residual?
The actual value.
Yeah. See, that was the actual value. I subtracted the predicted value.
Is that Roz?
The residual is the value you get from subtracting.
The distance between the 2 points.
Say it again.
The distance between the 2 points.
Okay, but it's not okay, I did not hear you my bad thing, but it's a distance between the actual point and the predicted or the trend line, right? That's what we're calculating. Make a note to yourself. What you have is a way to calculate the residual, but what is a residual? It's just the distance between a point and the predicted value. So between a data point and the predicted value. Okay? I'm going to come back to this in a second, but this ties into numbers 3 and 4. When that data point is above the trend line, is that a positive or negative residual?
Positive.
We see how it's literally a positive, right? Because the actual value is bigger. So with number 3, you should already have that it is a positive residual when the data point is above. But if you have a data point that is below, that residual is going to be what?
Negative.
So for number 4, the residual is
Negative.
okay?
Yep.
When you have the best trend line, you're going to have several that are positive and above the trend line and several that are negative below the trend line. And so if you add up all the residuals, you should get 0. Let me say that again. If you add up all the residuals, you should get 0. However, we want to know how far are those data points away, which is why they ask you to go in and add a residual square. If you square a positive number, what kind of number are you getting? A positive. If you square a negative number, what kind of number are you getting? A positive. So when you get these squares in here, all of those things are positive. So the residual itself is just the distance between a data point and the predicted value. The squares is literally a residual square. Notice how that's this distance right here? How far that point is away from the trend line? And so they have squared that residual to get that area there so that it's always positive. That's the whole idea, so that we can add up all those squares. Does that make sense so far? Ready to move forward?
Yep.
Okay, so that brings us up to number, I have it somewhere, there we go. Number 5. Did everyone at least play around with it to get number 5? Y'all did not get a chance yet? Is it? Y'all did though? So it's just group 5 that hasn't? Y'all haven't either?
I don't know if it's too
Okay.
right.
Huh?
I don't know if it's too right.
There is no way to have it too right. So I want y'all to have another 5 minutes or so. Work on 5 and 6. By the way, once you get maybe 10 minutes. Once you get done with this first paper, go to the second one. You should be trying to get to number 11 at least before we have a whole class discussion. Okay? So start on 5, try to get through number 11. Let's get to work. Did you gonna look for the other one? Did you ever look for the second paper? What'd you do with it from yesterday? So I gave you both of them today. Like when you came in.
It's like, right next to each other. Like they like.
No. Lois, you can get it. Yes, sir. Follow the directions up here.
Everybody else.
It's supposed to be the lowest on the squares you can get.
What's the number? Okay, then that's the answer. I can put it together. Look at your line.
Show residual
See how
squares.
many points above the line.
What number is this?
Look at the points that's up here. How many are up
You
here?
got 1, 2, 3, 4, 5, 6 data points above. Maybe 7. 1, 2, and there's 5 there, so 7 above. Or 7 below. That's all you're doing. How many points are above, how many points are below? There's 1 to 9 data points.
Miss Kim, I got
There's
it.
5 up here.
Yeah, I don't know how, let's see.
There's 5, 6, 7, 8
But
are
these like
below.
right in the middle.
But they're not. That's a little bit above, that one's a little bit above, that's above, above, above,
Okay, so
above,
let's
above.
see how many numbers.
Even if it's like right on the edge, if the majority of the points above, it's still above.
So that's 10. Yeah, you said it's 5 right here, it's not 6 right here. Wait,
No, I'm saying there's 5 all right here.
oh, that was.
So, once you get done with
At the beginning.
number 6, move on to 7, 8, 9, 10, and 11. Yeah,
It's 5.
you just hit Control Z.
At the top. I think
You
it's
shouldn't have a residual plot. Hit Control and Z.
It has like
like
a.
right up there.
Hey, you put 49.2, are you sure that's yours? Number 5?
You want analyze, if you follow your directions.
Yeah, like that's
But
5.
this is where it's supposed to just hit enter. Now click on the line so you can see that.
Alright, check with a partner. How does his or her value compare to you? If it is different, explain how. Because it's different.
You should color line is like,
Oh, of course, you still want to be
Yes, if you've already, yeah, that's 5 data points up there. Because it's 2001 and 2001.
No, he's talking about this. Yeah, he's talking about the square value. He said, how does his or her yeah, all of that is different.
mine 49.2,
I don't see a 49.
It's different because
No,
we put our.
the smallest sum of the squares.
Besides the one at the very bottom.
It says, what is the smallest value you can find for the sum of squares? Your sum of squares is 182.
Wait, how I
Mr. Kenny,
Mr. Kenny.
Kenny, Mr. Kenny, too.
It literally
Click
looks
on the
like
line.
it has things.
And look, we tell them, because they've been on the calculator all the time.
Your sum of squares, you want to make that as small as possible.
I'm about to, Mr. Kenny, at the beginning, doesn't it look like it has like equal space from like right here?
You just count the ones below and then ones above.
You gotta move the trend line,
You
make it
increase
smaller.
the squares. What are you trying to answer? Okay, what do you notice about the distribution of the
What is your value?
It says above versus below the line, or equal spacing versus cluster. So those are clustered up here, but everything else is pretty equally spaced. Okay, that's all. Okay.
Yeah, I think that's.
Well, what I would focus on for you is I would focus on what's above and below.
Miss Kim, is something wrong with your calculator?
Like, look, no, you're making it way too complicated. Just look right here.
How you get off of?
Which of those is gonna increase the sum squares most? How do you know? Furthest away from the line is the biggest square. That's it.
Miss Kim, is something wrong, Miss Kim, something wrong with your calculator. No, it should come out by.
We can do it.
And then they take it back.
It times out.
You don't need to time out there. Alright, Miss Kim, we on number 8. I don't really understand what you asked me.
Which data points increase the sum of squares most? When you look right here, which of those points do you think is increasing the sum of squares the most?
Because they have big numbers like
That's all I'm saying.
Oh,
What increases the sum of squares the most? The ones that have the biggest squares, which those points are they further apart or closer to the line? That point is closer to the line than these points.
They did in middle school, but that don't mean you wanna do it now.
That's all I want you to look at.
so the ones.
You wanna do trade? You wanna be on trade? I'm a sign. What?
All-stars. You can go to state.
Maybe it just go like.
My team, you got two D1 athletes in your.
Call my dad.
On the track team. You got another one right there.
Okay.
We're working on. I'll tell y'all that.
Let's move on to 8 and 9. Focus on 8 and 9.
I'm probably not gonna put cars on.
They wait like Phoenix, Illinois,
You don't need it just right there.
If you were talking about the map, this would be a problem. No.
Anyways, they didn't call me. I called
Yeah, we did call it. I look. So we made the chill out, I mean, we should have to I made my smile good.
That's your last name. Your last name's so long.
Rotate your line. Don't just move them down. Stop. I told y'all that you had rotate the line.
By the way, that's a weapon.
Oh, that'd be way smaller, didn't it?
You can make it small on this side too, go even
No, I
smaller.
wrote it like that.
When you said
But I need y'all to focus on 8 and 9 at this point.
when you said
It's up right there. Shut up, boy, this is right there. You know.
It's 1920 from,
Dale.
we're on 11.
you just hold down on it.
I won't feel like we got enough from 10.
We're gonna talk about it.
Miss Kim just told me that.
Thank you, thank you. Thank you. Alright. So, what is the smallest value that y'all found for the sum of squares? 60? 54?
49.2.
66?
49.2.
49? Anyone get below 45? I didn't even realize I had that, it was just there.
I got 43.7.
43.7? So here's what I want y'all to notice. The question earlier was, is there a trend line that is best, or a regression line that is best? What do you think we want to have the best trend line?
The lowest sum of squares?
The lowest sum of squares. Fundamentally, what I first need you to recognize, we're going to get into this in a little bit, but I would write down, right, so it says move the line to minimize the sum of squares. The best regression lines minimize the sum of squares, okay? When you do that, there's a couple of important details here. When I look at mine, I have 1, 2, and then that's 5, so 7 data points below the regression line. Okay? I have 1, 2, 3, 4, 5, 6, 7, 8 above the regression line. Yep, there's a total of 15 points. Okay? Did anyone get something other than roughly splitting it 7 and 8?
I got one that's like on both sides. What do I?
Well, it's like evenly split, so 7, 7, and then 1 in the middle.
Yeah.
That's fine. Okay? But I want y'all to notice, overall, because it's going to matter, if you have a good trend line, right? Notice, did anyone do a trend line that looks like this? Notice that would have 3 data points above the trend line and a whole bunch below. So in general, we want that trend line to do what to the data? Split it, right? We want that trend line to split the data. And we're going to go into more detail about this later. So, but number 6, how many of the points are above or below your line? That should be about the same. It doesn't have to be exactly the same as mine because did we all have different trend lines? Yes, and that's fine. So which data points, number 8, this is important. Which data points increase the sum of squares the most?
The ones which are farther away from the line.
Data points that are further from the line have a bigger what? Bigger square. When we look at number 8, the data points further, hey y'all, we should be writing this down for number 8. Make sure we have this idea. If it's a little different, it's the same, it's okay, but the data points furthest from the line, from the regression line, have the biggest squares. Okay? The data points furthest from the regression line have the biggest squares. Alright? Next page is where we need to focus. Number 10. What do you notice about the distribution of the data points around the line? Okay? We already mentioned that the trend line needs to do what? There was a word that I think Jordan used that was really good. It needs to what? Split it. Okay? This is number 10. Right? I need the other sheet. That's right, I gave away my other sheet. Huh? No. No. You can go grab one over there. Okay. Oh yeah. This is kind of a sum for numbers 10 and 11. This is one of the most important ideas. So a combination of numbers 10 and 11. In order to have the best regression line, what do we want our data, what do we want the line to do to the data points? We want to split it, and there's something else. The trend line, or the regression line,
You put this on both of them?
you just put it under one, but it's answering both of them. The regression line should split the data, and the data should be scattered. And what I mean by that is there should not really be much of a pattern. Okay? There should not be much of a pattern. It should be fairly scattered, which we have a good bit of scatter there. Okay? So, here's what we now need to do is the technology part. Because you do not want to have to go through the process of getting the least sum of squares every single time, right?
No.
Technology is a beautiful thing. So, what I want us to do right now is using the calculator here, what are the directions above numbers 12?
You, analyze.
So go to menu, then analyze, and then go to regression, and show linear regression, right? So go to regression and show linear regression, okay?
You see that?
It should be the top of regression, okay? Now I want y'all to notice, does anyone have a different equation than the one I have? Y equals 0.266129 x minus 454.364.
No.
No. This, y equals mx plus b, okay? This equation is unique. What do you think this equation does to the squares?
Animal. Small. Something.
Makes them smaller. Remember, what do we want our sum of squares to be? Small, okay? Small as they can be. Let me check one thing really quickly. With that highlighted, go back and add your residuals. It should already show it, but it's not. Okay? So with the equation that we just graphed in there, go back and show your residuals.
How you do that?
Remember menu, analyze, y'all did this earlier.
Residuals.
Residuals, show residual squares. What's the sum of those residual squares?
41.
You want to stop?
Jump put a part of it. Oh, you have to highlight one of the lines.
Don't tell me if I.
There you go.
No! Let's get a little. I'm gonna.
Okay, did anybody get something smaller than 41.09? No, and I'll go ahead and tell you, you cannot get a sum of squares less than that. This equation that we just got, or this trend line that was just put in there, is known as the least squares regression line. Okay? Anyone want to guess how I'm going to abbreviate this so I don't have to write it every time?
LSRL.
If you ever see me write LSRL, or anybody, we are talking about the least squares regression line, which means we found the best and okay or the worst trend line.
The best one,
The best one, because what is that least squares regression line doing?
it reduces the amount of squares.
It's reducing the sum
Or the sum
of squares, right? So don't forget, that's what the least squares regression line is doing, is it is finding the absolute best trend line to reduce those sum of squares. It's getting as close to that data as possible. We good on that? Any questions about that?
Nope.
Okay. Apparently I just skipped. Oh, that's what I did. Alright, so we need to take a couple of quick notes before we have an exit slip. So, number 12, what is the value of the sum of squares when we have that least squares regression line?
41.09.
And so we want to know that, hey, that is smaller sum than anything before. Okay? Yo.
I'm sorry.
So, how does the regression line differ from your line? Hopefully not too much, right? Because what did we do in order to get our regression line earlier? We tried to minimize the squares, okay? So, generally pretty well. Let's mostly focus on 16 and 17. Okay? So I want to remind you, okay? We got a slope and a y-intercept. Can someone read off that equation for me?
Yeah.
But which one?
Where?
On
From
the
the calculator, the
calculator?
least squares regression line?
Who made it?
0 point.
2, 6.
Wait, 2, 6, 6, 1, 2, 9, times 6.
I think it's plus a negative, right? So minus.
454.36.
Hey, y'all, I need y'all to focus up. Okay? This is the least squares regression line. What is that equal to? Where? It's okay.
Equal Y.
Is it equal to y?
Yeah.
Oh,
X
It's
is M.
to
X.
M of it.
Some of
I'm missing something.
what?
The hat.
What is it?
The hat.
Oh, yeah.
Because are those the actual y values? No, they are the what?
Why am I saying hair?
Because the hat is.
What is that hat telling us? Predicts the data values, right? We are predicting. So,
Right, so 16.
under number 16, so interpret this slope. So don't forget, this is divided by what?
It's
1. So understood to be divided by 1. The rise, right? So my slope is my rise. What is the y value in the data set?
The 0.2. Wait, the
What was the variable? Like what did it stand for?
Persons?
A person's what?
life.
Life.
Span. It's expect something.
How long they expect to live, right? One what?
1
Year.
Yeah.
Remember that was the x, that was the years, right? So, for every 1 year that goes by, so for every 1 year that goes by, what do we expect to happen?
We expect them to live 0.26.
What is that 0.266?
That's their life expectancy.
We predict the life expectancy
To go up by.
to go up, or to increase by 0.266 years. Right? That's interpreting the slope. You gotta know how to do that. That's my slope. What about the y-intercept? What is a y-intercept?
What a line crosses the line.
Okay, so what do we know about every point on the y-axis? Think about, I know one of the numbers for the y-intercept every time. Which one is 0? Y'all, yes, it's in the middle, but which value, the x or the y, is 0?
Y.
This is an x of -1, this is an x of 1. So all of these have an x of,
Y. X.
an x of what? An x of what? Thank you. If we have a y-intercept, we know the x value is 0. The y value is -454.36. So when the year was 0, the life expectancy was what? -454 years?
So how people live.
Is that possible?
Negative.
No. This is why it is bad to use trend lines to figure out stuff outside the data set. Okay, we'll talk more about this tomorrow.
He's gonna say exit slip.
I am about to send you an exit slip.
Yes.
Alright.
Okay? Hey, y'all need to hurry up and do this. Number 2 is the only one that should be, hey, listen. Number 2, if you have a technology issue, let me know, but none of these questions should take very long. Huh?
I haven't taken long.
You haven't even tried. What? Okay, go to browse. Go down to squared up formative assessment.
Wait, what is it?
Hit enter.
Hey, how's your
Save.
phone going?
What's his name?
No, we're.
They used to say it ain't supposed to have it like so much sleep. So it's not supposed to have it.
Correct.
No, I'm not, Mr. Kenny, you don't be sending this stuff.
I do. Just cancel.
I did. It's Kenny, which thing was supposed to done? What's today's date? 25th?
No, don't say that.
Hey, can you come help me with this calculator?
So no. No. And they don't open. What's up? Go to browse.
What's up?
Oh my gosh, you haven't even looked at it.
Students, please pardon the interruption. When the bell rings, I need to see the following students in Mr. Thomas's office: Gabe Dinsmore, Jock West Connor, Isaac Burns, Kristen Lucius, and Dayla James. Thank you.
If you are having trouble, what are you trying to do? Your input's already right there. Grab it and move it. Where do you want to be? Y'all need to complete these 4 questions before you get out of here. Please don't forget, I need your release forms. And you need to be, most of us should be working on test corrections yet. I think one of us has come to tutoring at this point. Where's the formative assessment? No. Make sure you put your calculators up. My next class is not using them.
So we don't have to per se. He said he played Fortnite. Oh, good night. I got his name, Fernando 15.